Okay, so let's finish up here, and let's talk about lines a little bit more, and specifically finding equations, finding an equation of a line. Because we will be doing that, and I'll just show you how I do it. You may know another way using a different sort of technique, and that's fine. Do it that other way, but here's the way I typically do it. All right, so let's say I want to find the equation of the line. That goes through the points and it's going to be 8, -6, and the other one is 12, 9. All right, so my deal is we're looking for an equation of a line, and typically what we like on equations of a line is the final answer anyway, for sure, y equals mx plus b. So that's what I always say. I'm looking for the equation of a line, unless it's vertical or horizontal line. This is the form I'm looking for, y equals mx plus b. So to get this equation of a line, you need two things. You need m and you need b. M, of course, is the slope, b is the y-intercept. Well, we're not given either one here, right, because neither one of those is the y-intercept, and yeah, we don't have the slope, but we can use our slope formula to get the slope of this line because we have 2 points, and again, the slope formula is the difference of the y's over difference of the x's, or x2 minus x1. Sorry, y2 minus y1 over x2 minus x1. Definitely a formula worth knowing, right? Known already. But it's just the difference of the y's over difference of the x's. You take the second y, 9, minus the first y, -6, so we got the old double negative there. And then divide by second x, 12, minus first x, 8. And then evaluate there. Which brings us to, yeah, I got the double negative, so that's 15. 12 minus 8 is 4. Okay, so the deal on fractions, I may have mentioned a little bit before, but yeah, if it's a decimal that terminates, use a terminating decimal if you want to, which this one does. The book likes the reduced fractions, especially if it's a repeating decimal or something like that. They like the fractions, so let's just leave it. I mean, we could, what is that, not round it, but change that to the decimal equivalent, 3.75 is what that would be. If you do that, that's fine. That would be fine in this case. The book will probably leave it as 15/4 for their answer, so let's deal with that here, see what happens. Yeah, so that goes in for the m, so it's 15/4 x plus b, or 15/4 times x. Yeah, so that's, this is where maybe you might utilize a different, there is that point slope. The one I'm referring to is the point slope form of a line. If you like that form, go right ahead, use it. You may see the book use it as well, but I just typically, say let's do y equals mx plus b, and we'll figure out the b from this. The way we figure out b from this is, yeah, if we use, this is an x comma y that we can plug into x and y here, just like we can plug it in for x and y's over there. That's an x and y. The x is 8, y is, now, in this case, we do have 2 options, right? We could use x, y is 12 and 9. Take your pick. We just use this one as x and y. You got x is 8, y is -6. So that's how I usually do my figuring out what b is problems. And that turns out really nice. 30, yeah, it's just 30. So all you have to do is subtract 30, you got your b. And the only thing on this is, yeah, that's not the answer. The answer is plug that in for B. Our final answer is y equals 15/4 x, and then the B is negative 36. Right? Did I do that right? Yeah. Yes. Okay. One other little tidbit here. On this particular section, for whatever reason, I don't know why they chose this. What you might see on this one, this is usually what we want. That's what we're going to want. But they add a little extra piece. I guess they're technically saying, well, I'm telling you to find the line segment. I think they may even say line segment through these points. And so the line segment through those points is y equals 15/4 x minus 36, which is, you know, whatever it looks like, 8 negative 6, 12, 9. What? Let's see. Eight negative 6. 12, 9. Yeah, something's not right here.
Are you going the wrong way with the 8?
Oh, I did. That's what it is. Okay. 8 negative 6. All right, yeah, so that, all right. I was saying that ain't right. But yes, thank you. 8 is over here. Just check.
Like the calculator says it is.
All right, well, besides my little blip there, so that's that line. They say, well, what's the line segment between these 2 points? All right, and so they're just wanting this right here, from here to here. And so it cuts off, you know, the domain. They're only wanting from x equals 8 to x equals 12, and so that's why you might see this little extra piece. It's just because of what they're asking. We won't ever want the line segment, just the line segment between those two, so I don't know why they did that here. I guess maybe just to get us to think about it. So it's good in that makes us think about what they ask. Be sure to answer their question, I guess is the point. But typically, we're just wanting the line. So just FYI, that's what that means. It's just they're limiting it to that piece of the line. So, all right.